Welcome to part 8 of this series on global warming. Previously, part 7 of this series took us back 2.4 billion years to the beginning of the 5 known ice ages. And from there, it brought us up to the start of the present Holocene epoch. During this video, we will look at the numerous changes to the climate that took place throughout the Holocene interglacial period, right up to the year 1850, at which point the Little Ice Age came to an end and the modern period of climate change began. We will use the information gained to identify the crucial question that the IPCC is unable to answer. We start the journey not at the exact beginning of the Holocene, but at around 20,000 years ago. This was when the transition from the last glacial period to the Holocene interglacial period started to take place. This time period is commonly referred to as the last glacial maximum. It was a time of intense cold and can be regarded as both the peak of the last glacial period and the beginning of its termination. At that time, the world was on average probably about 10 degrees Fahrenheit or 5 degrees centigrade colder than today, and in some local areas as much as 40 degrees Fahrenheit or 22 degrees centigrade colder. Ice sheets were at their maximum extension in recent history. Vast ice sheets covered much of North America, Northern Europe and Asia. The enormity of the ice sheets caused a significant drop in worldwide sea levels. It is estimated that the sea level was 120 meters lower than it is today. It is worth looking at just some examples of what were the practical effects of these low sea levels and vast ice sheets. As can be seen from this diagram, 20,000 years ago, Great Britain was not an island. The low sea levels meant that Great Britain was at that time connected to France by land. Also at this time, the low temperatures and the extent of the ice sheets drove human beings south, so that England, Germany and the northern half of France were practically depopulated. However, from these extremes of the last glacial maximum, the climate started a slow transition to warmer temperatures. This continued until around 12,800 years ago. As a result, the previously enormous ice sheets started to melt. This in turn caused a mean sea level rise of approximately 130 meters. I am reasonably confident that if we were climate scientists at this point, then we would have identified a strong trend to warmer temperatures and might well have predicted this trend to continue for some time to come. However, we would have been wrong. The transitional trend to warmer temperatures did not follow a smooth path. Instead, it was interrupted by a cold snap named the Younger Dryas. This snap lasted in fact 1,300 years. At the beginning of the Younger Dryas, the global average temperature fell rapidly by about 2 degrees centigrade in under 50 years. In Northern Europe, average surface temperatures dropped by some 5 degrees centigrade. Isotope data from Greenland Ice Core GISP2 indicate that the summit of Greenland was approximately 15 degrees centigrade colder than today. The much larger cooling in Northern Europe compared to the global average has been attributed to a possible change in the Atlantic Ocean thermohaline circulation. You may remember we discussed this Atlantic circulation in part 4 of this series. The vertical blue line on this chart clearly shows the drop in temperature and the accompanying rise in fresh water during the Younger Dryas. It also indicates that the end of the Younger Dryas seems to have come about very abruptly. We can see that temperatures rose sharply, and as an example, which is not explicit in the chart, in Greenland, temperatures rose 10 degrees centigrade, that is 18 degrees Fahrenheit, in 1 decade. The end of the Younger Dryas effectively terminated the last glacial period and marked the beginning of the Holocene interglacial period. There are varying dates given for the start of the Holocene, but we will use the IPCC standard, which gives the start as being 11,500 years ago. For your information, the dates given by other authorities do not vary significantly. From 11,500 to 10,500 years ago, the volume of cold fresh water decreased and the flow of tropical waters began again. This produced a rapid warming of global temperatures. To be specific, over a period of 50 years or less, the global average temperature increased by about 3 degrees centigrade, while temperatures over northern Europe increased by 7 degrees centigrade. This resulted in further contractions of the ice sheets, which in turn led to humans repopulating northern Europe. Access to Great Britain would have been easy, as it was still connected to France by land. The warmth may have brought about one casualty, however. While the woolly mammoths survived and perhaps thrived during the cold of the last glacial period, the warmth of the Holocene brought about their extinction around 10,000 years ago. The exact cause is not known, but it could quite possibly have been a combination of the increased temperature in itself, plus the spread of mankind and their increased hunting. After the demise of the woolly mammoths, the transition to a warmer climate continued, in different parts of the world and at different rates, until we arrive at 9,000 years ago. The time between 9,000 years ago and 5,000 years ago is known as the Holocene climatic optimum, or as the Holocene maximum, or as the Holocene optimum, or several other names, depending on which authority you are reading. Whatever the name, this period continued the previous warming trend, and our planet experienced 4,000 years of benign temperatures. The Holocene optimum is also known as the Holocene wet phase, due to the increased rainfall during this period. It is no coincidence that during the Holocene climatic optimum, many of the Earth's great ancient civilizations sprang up and flourished. For the warmer climate and increased rainfall were ideal conditions, as they provided greater availability of surface water, vegetation, and animal life. For example, in Africa, the Nile River was 3 times its present volume. And 6,000 years ago, the Sahara was far more fertile than today, and even supported large herds of animals. The Eastern Sahara was occupied by hunter-gatherers, and in some parts, the introduction of domesticated animals took place. While the overall increase in temperatures during this time is not in dispute, there is a dispute over the claim that during this time, average global temperatures reached their maximum level compared to any other period throughout the Holocene, and may have been 1 to 2 degrees Celsius warmer than they are today. What seems to be beyond dispute is that the warming trend was not uniform across the planet. While there were increases of up to 4 degrees centigrade near the North Pole, and the northwest of Europe did indeed get warmer, the south of Europe seems to have experienced some cooling. In fact, it looks as though the average temperature change declined in tandem with latitude. A good summary of the period might be that while temperatures in the northern hemisphere were warmer than average during the summers, the temperatures in the tropics and areas of the southern hemisphere were colder than average, and that the average global temperature was at least comparable to that of present times. Also not in dispute are the large-scale changes to the structure of the planet. Many of the common features we often take for granted as having existed forever actually came about during this period. We will briefly look at Great Britain and the North American Great Lakes. The shape of the modern British coastline and landscape began to emerge around 10,000 years ago. That's 1,000 years before the start of the Holocene climatic optimum. The land, which had been a dry tundra during the last glacial, gradually grew warmer and wetter as the ice caps melted. But 10,000 years ago, the Irish Sea, the North Sea and the English Channel were still all dry land. But over time they gradually became submerged as the sea levels rose. Eventually, around 8,000 years ago, the English Channel filled, and Britain and Ireland became the islands they are today. If we now look at the North American Great Lakes, 20,000 years ago, at the time of the glacial maximum, the Great Lakes did not exist as they are today. However, across the proximate areas of the modern lakes, there did exist what are known as proglacial or ice frontage lakes. These proglacial lakes were water and ice dams in effect. They were formed, usually, by retreating glaciers. During the Holocene climatic optimum, the glaciers retreated further and further, which, putting it very simply, caused the proglacial dams to burst. Much of this enormous amount of fresh water escaped to create massive pulses of fresh water which poured into the world's oceans. But enough of the water remained to form the Great Lakes, much as they are today. The exact timing is still being studied, but most of the formation of the Great Lakes seems to have taken place by 8,000 years ago. Following the Holocene climatic optimum, there followed a period lasting just over 4,000 years that could be called unstable, in that there were multiple subperiods where frequent changes in the climate took place. We will briefly look at the most prominent of these subperiods. The first subperiod we will look at occurred from 5,000 to 4,000 years ago. It is an interesting time in that the climate changes produced features that today we regard as normal, but in fact did not exist before this time. This came about because during this 1,000 years, a cooling trend occurred. As would be expected, this cooling caused large drops in the sea level and, as a result, the emergence of many islands and coastal areas. Many, if not all, of these islands and coastal areas are still above sea level today. For example, the Bahamas emerged at this time. It is interesting, although alarming, to consider the threat posed to the Bahamas should sea levels return to where they were 5,000 years ago through quite natural fluctuations in the climate. Following the 1,000 years of cooling, a short warming trend took place from 4,000 to 3,500 years ago. But after this quite short time span of only 500 years, colder conditions returned. From 3,500 to 2,750 years ago, approximately, these colder temperatures caused renewed ice growth in continental glaciers and alpine glaciers, and a significant sea level drop of between 2 to 3 meters below present-day levels. Once again, however, the climate changed, and during the period from 2,750 to 2,150 years ago, the average temperature once again rose quite significantly. For perspective, however, it should be noted that the temperatures at this time did not get as warm as that during the climatic optimum. Before moving on to the next sub-period, I would like to alert you to a change in the way I will refer to dates going forward for the rest of this video. Up to this point, I have used the convention of years ago to refer to events taking place so many years ago from the present being approximately 2014 AD. However, many of the next periods are commonly dated in the literature using the BC and AD convention. So to avoid confusion, or in an attempt to avoid confusion, I will switch to this convention for the rest of this video. So I will now refer to the next period not as beginning 2150 years ago, but as beginning 150 BC and continuing to 900 AD, a period of 1050 years. During this period, a cooling began, which culminated in the so-called Dark Ages. This occurred from 600 to 900 AD. During this time slice, global average temperatures were significantly colder than today. At the height of the Dark Ages, the cooling caused the Nile River to freeze in 829 AD, and the Black Sea to freeze between 800 to 801 AD. After 900 AD, a transition to a warmer climate began. This led to the next period we shall examine. Before doing so, this is a good point to take stock and assess how these extreme changes to the climate affected we human beings. In fact, throughout this period of almost constant change, human beings and their civilizations thrived. From 5,000 years ago to 950 AD, the following civilizations and empires rose and flourished: the Roman Empire, the Greek civilization, the Chinese dynasties, the Indian Indus Valley civilization, the Persian Empire, and the Mayan civilization. They all represent a tribute to mankind's innate ability to adapt to the climate. With that pleasing thought, now might be a good time for a tea break before moving on to study the medieval warm period. The period 950 to 1250 AD is most commonly known as the medieval warm period. As is the case with other periods of climate, it also goes under other names, such as the Little Climatic Optimum, or the Medieval Climate Anomaly, or the Medieval Climatic Anomaly. Whatever the name, the period in question represents the warmest climate since the climatic optimum. Indeed, it is often claimed that the medieval climate anomaly was warmer than present temperatures. Of course, as you might expect, this is disputed. But, as this statement shows, the IPCC itself does recognise with high confidence that there were multi-decadal periods during the medieval climate anomaly that were, in some regions, as warm as in the late 20th century. There is ongoing debate and research into the global temperatures of the medieval climate anomaly, And looking back over the judgments that have been made over the past 20 years, it is clear that the jury is still out on whether the medieval climate anomaly was in fact as warm overall as in the late 20th century. But we can say with some confidence that it was pretty close. And for a full understanding, we need to take into account other types of evidence. For example, during this period, the Vikings established settlements on both Greenland and Iceland, and they made farming productive on Greenland. This feat has not been reproduced since that time. In addition, the snow line in the Rocky Mountains was about 370 metres above the current level. Grapevines were grown in England, and wheat was grown at 64 degrees north latitude in Norway. There is thus a large amount of circumstantial evidence that points to the medieval climate anomaly being as warm as the late 20th century. After the medieval climate anomaly, there followed a period of 1,000 years where the climate and associated weather was both cooler and more extreme. There are records of floods, great droughts, and extreme seasonal climate fluctuations during this 1,000-year period. To quote some examples, severe floods were experienced in China in 1332 AD. It is believed that several million people lost their lives as a result. And between 1276 and 1299 AD, a great drought occurred in the American Southwest. Tree ring analysis has identified this as a period where virtually no rain fell at all in that area. After these extremes of weather, temperatures continued to fall, and during the next time slice from 1350 to 1850 AD, temperatures reached their coldest since the beginning of the Holocene. As a result, some climate scientists call all of this period the Little Ice Age, while others, such as NASA, say that 1350 to 1550 AD should not be classified as the Little Ice Age, even though agreeing that temperatures were falling during this period. They would prefer to classify the Little Ice Age as occurring from 1550 to 1850 AD, with 1350 to 1550 being seen as a transition to the Little Ice Age. Perhaps, as we have it in this chart, it can be best summarized as being divided into two phases, the first beginning around 1350 and continuing until around 1550. In fact, there was a slightly warmer period in the late 1500s, after which the climate did deteriorate substantially. And then, at this point, it is not disputed that the second phase, which lasted from 1550 to 1850, is universally known as the Little Ice Age. During this second phase, global average temperatures were only 1 degree centigrade or less cooler than in 1900. But in Europe especially, the effect of the temperature drop was substantial. For example, the glaciers once again advanced down the mountains, and in the Swiss Alps, residential houses were covered. In Holland, canals froze for up to 3 months straight. In London, the River Thames froze over. While these impacts are clear to see, in terms of the effect on day-to-day life, perhaps the most significant impact was the drop in agricultural productivity. In some parts of Northern Europe, agriculture actually became impossible. We have seen before that a period of intense cold, such as that which occurred during the Dark Ages between 600 AD and 900 AD, can be followed by not only a warm period, but by an exceptionally warm period, such as the medieval climate anomaly that followed on immediately after the Dark Ages. So we should not be surprised that following the Little Ice Age, the world has once again started to warm up. So why are we alarmed that this is happening? For me, it can only be because the IPCC claims that the world is warming faster than it would normally. But, and here we come to the major point I want to bring out. In order to determine that the world, due to the increase in greenhouse gases, is warming faster than normal, we must first be able to determine what normal is. To do that, the IPCC must first be able to answer this question. By how much would the world have warmed if the carbon dioxide level had remained at its 1750 level of 280 parts per million throughout the 20th century? I am quite certain that the IPCC cannot answer this question. What are my reasons for this? There are three main reasons for my certainty. 1. The IPCC has not published the answer to this question in any publication I have read. 2. The immense complexity of the question. Just think how difficult it would have been for climate scientists to predict that after the cold of the Dark Ages, there would follow the medieval climate anomaly, or after thousands of years of warming at the end of the last glacial period, suddenly the cold Younger Dryas period would kick in. And finally, reason 3. The IPCC has so far been unable to accurately predict the warming trend of the late 20th and early 21st centuries. So how could it possibly calculate what would be normal for these periods? So those are my reasons. The IPCC or its supporters can easily prove me wrong by publishing the answer together with the supporting calculations. I won't hold my breath. Instead, I will conclude this video with the following remarks. During this series, we have studied many periods, but just studying the Holocene alone has shown quite clearly that over time there are quite natural changes in the climate, and that these changes can occur over quite short periods. They further demonstrate that the causes of the changes are the complex interactions of natural phenomena. There does not have to be a single evil cause, such as, for example, increases in carbon dioxide levels. And we should remember that throughout the Holocene, carbon dioxide levels remained almost constant. Yet, persistent changes to the climate took place. Thanks for watching this video, and I leave you with its major conclusions, plus of course the question the IPCC cannot answer.